All right, Maria, what was our vertex? Good. So 1, -4. Then we're going to graph that. On my graph, I'll make one of them thick so that we can kind of determine that this is your x-intercept and your y-intercept. So I'll say this x. There's my y-intercept. And then we'll plot the point 1, -4. So, all right. Now, we could, if we want, do a little XY chart, figure out all those values, but that was kind of a long process. The other way that we're able to graph this now is the x-intercepts. So again, old idea, the way we find our x-intercepts, if you remember, write down the original problem at the top of the paper. So what I have right here, rewrite this in part C. This is what we called standard form. Your x-intercepts are when obviously we cross the x-axis. Whenever we cross the x-axis, that always means that your y value is a 0. So remember how we set those equal to 0? And then I would tell you to factor this. So we just took this test. Oh, I don't want to give all of it. Try to factor this. See if you remember how to do that. By that I mean we tried to find numbers that multiply to be a -3. And those numbers also needed to add to be a -2. Not a lot of options. We should get to those numbers pretty quickly. There's not a lot of ways to multiply to get a -3. All right, what numbers work? What multiplies to be -3, add up to be 1? Hannah? Good. -3 and then a +1. Now that that's set equal to 0, this is when I would then always now ask and go around and say, all right, well, what x value makes this guy 0? So what x value makes this first factor a 0? And Sarah, that would be what? Good. +3. And then same thing with the other one. If I ask you which here, Catherine, which would make this x plus 1 into a 0? Good. -1. Those are your x-intercepts. So then we go to the x-axis at a +3, you put a dot. On the x-axis at a -1, we put a dot. And with the intercepts, with our vertex, we can now sketch in our parabola. Okay? All old stuff. We did that for 5 weeks, took a test on it. Some of us did on the corrections on it. So it's been a week or two, but hopefully that comes back to us a little bit. So that's what we did before. So now let's go to number 2. Do this for me. Go ahead and put it into vertex form. So make sure we know how to do that now. We reviewed it here a minute ago. So put this thing here into vertex form. See if we can now do that on our own real quick. All right, once you have it, go ahead and plot that. Well, write the vertex. I wouldn't plot it yet, just in case maybe you made a little error. But then that should answer part B as well. Once it's in vertex form, you should be able to look at it and state our vertex. All right, let's see what we got. We should be pretty close. I'll use the square again. If you don't have to use the square, don't use it. But it's a nice model. So x squared is going to be x and an x. And then again, this middle term, if it's a square, had to get split evenly between this corner and this corner. So that would have meant that there's a -3 in each of the corners. All right, so then right here, to make that a perfect square, mark, that's going to be what? Good. So that should be a positive 9. So if I now add a positive 9 right here to make this into a perfect square, I would then subtract that 9 from the 4 on the back end. We can now write this as f of x equals, and then think about what we have in our square. This is right now x squared minus 6x plus 9, but this would have been an x minus a 3 on the top and an x minus a 3 down the side. So it's just 2x minus 3's. So we write that as x minus 3 squared. 4 minus 9 is a negative 5. So crossing my fingers, hopefully we all got 3, negative 5 as our vertex. If not, there you go. Okay, that's how that should have played out. Plot that point then. So let me make a big XY plane here. So there's my x-axis and my y-axis. And 3, negative 5 is our vertex. 1, 2, 3, 1, 2, 3, 4. All right. What we now want to do is go to part C. To find our x-intercepts, you're going to factor this. So rewrite that original equation again. So the original equation, let me make this smaller, was f of x equals, what was it? X squared minus 6x plus 4. So our x-intercepts are when y is a 0. All right, now try and factor that. So numbers I multiplied before add up to be negative 6. Because those tell us where we cross the x-axis at. Okay, anybody got these? Anyone? All right, that's a good thing because this guy doesn't factor. If you came up with those, you're pretty clever because there's no way you can multiply two numbers to give you a 4 and then get that negative 6. All right. So if I now ask you to find the x-intercepts, and remember the x-intercepts are also what we would consider solutions or our zeros, you can't factor this one in order to figure that out. What that means is, so let me kind of show you these graphs. So I'm going to show you this first graph, the one that I drew in red here, the one that you have up in number 1. When I hit that graph, notice how this goes perfectly through negative 1 and a positive 3, just like the one on the top of your paper does. All right. So this is nice. If I go and graph the second one, it doesn't mean we don't have any x-intercepts. They're just not going to be nice. So if I now graph the second one, this is the second one that we just looked at. Doesn't this one also cross the x-axis at 2 different locations? So there are x-intercepts. It just doesn't factor. So now look, doesn't this appear to be a decimal of some sort? Somewhere between 5 and 6 is the answer. And then here, somewhere between 0 and 1 is the answer. So the fact that it doesn't factor means these are going to be kind of ugly. They're not going to be these nice whole numbers like we just got for the first one because it doesn't factor. All right, so instead of getting nice numbers like 3, negative 1, here we're going to get some ugly numbers, but we can't do it with our current method. So what that then leads to is the next page. Now go to the next page because now the question is how can we find those if it doesn't factor? And the way that we are going to do that is called the quadratic formula. All right. So when we cannot factor a quadratic, and that's what just happened in that previous problem, we could not factor it, we can use the quadratic formula to find our solutions. We don't have to skip them. So standard form for a quadratic, remember standard form is this guy. That's a squared term right there. That's standard form. We had standard form last chapter, we had vertex form, and we had factored form. This is standard form. What I want you to kind of notice is there's an x squared term here. Wherever your x squared term is at, whatever number is in front of the squared term, that's your a. So if you look at this formula right here, notice how there's some a's in the formula. You're going to get that a value by whatever number's in front of the squared term. Okay? Notice how there's a b in this formula. There's a b right here. There's a b right here. The b is going to be the number that is in front of the x to the first term. So whatever that number is right here, you're going to assign it to this location and this location in a minute when we do the problem. And then last but not least is your constant. Notice how there's a c in here. The c is the number that's all by himself without a variable. Okay. Once we identify those, although it's ugly on your paper there, we're just plugging into this formula here. All right. So what I want you to do first, we're going to do this very first problem. Recopy this problem, x squared minus 2x minus 3. So we're just going to do problem number 1 from the front page. And we're going to do it in this space in here. So go ahead and write, this is number 1 from the front page. X squared minus 2x minus a 3. So find some room in there to do that. And then we'll kind of show how this works. So I need to identify what is my a. So a is the number in front of our squared term. So here is the squared term right here. Notice how there's nothing written in front of it. So that implies that there's just a 1 right here. So our a is going to be a 1. Then we need to identify what our b is going to be. The b is the number in front of the x to the first term. So here is x to the first. The number in front of that is a negative 2. So the variable b is a negative 2 in this problem. And then last but not least, the c is the constant that's hanging out at the end all by himself. That is a negative 3. So we want to identify those right off the bat. All right. So now we're going to plug those values into this formula right here. The first thing you're going to see, you see this little negative b. So what that means, I'm going to go to b. The negative just means I want the opposite sign of what our b currently is. So do we all agree our b is currently a negative 2? So when we substitute this in for a negative b, it's going to become a positive 2. Then you're going to see the plus minus. So then you're going to put a plus minus. Man, I don't know why that's so blurry. I'll make this really big. All right, then you're going to see this big, long square root. So you're going to draw that in, big, long square root. Underneath that square root, you were then going to square whatever b was. So again, our b is this negative 2 over here. So go ahead and do a negative 2 squared. Then you have the minus 4. So then do minus 4. And then you're going to multiply that by a, and then multiply that by c. So I'm going to do times a. A is a 1. All right, we got that right here. And then we're going to multiply by c. You can't see mine on mine right now, but the c was the negative 3. So all that goes underneath the radical. Then you have your big long fraction bar. You're going to do twice a. So I'm going to do 2 times whatever a was. A is again that 1. So we need to identify, we need to make sure it's in standard form, then find your a, b, and c, and then you're just going to plug them into the formula. Okay? Now from here, we just need to clean this up. So now we're just going to do some cleaning up. So we're going to say that equals the 2 plus or minus, nothing we can do with that. But underneath the square root, a lot of stuff can be done. All right, so first, if I do a negative 2 squared, so a negative 2 times a negative 2 should give us a 4. So put a 4 there. Then you're going to do minus 4. So do that. So minus the 4. Oh, wait. No. We already did it. Hold on a minute. The next part. Be really careful with this. As we even get better with this, this is where the biggest mistake is going to get made. We now need to multiply all 3 of these numbers together right here. So if we did that, negative 4 times a 1. Do we agree negative 4 times a 1 is a negative 4? But then I need to take that negative 4, multiply it by a negative 3. So what's a negative 4 times a negative 3? 12. And it's positive, right? So this becomes a positive 12. And then all of that gets divided by, this is a 2 times a 1, which is just 2. All right, so it's a little cleaner now. Look underneath your radical. We can now go ahead and do 4 plus 12 and make that a 16. Then, Haley, what is the square root of 16 going to be? Good. So we're now going to write this as 2 plus or minus a 4 over 2. Remember when we were solving these equations the other day, that plus minus actually means 2 different signs, the positive and the negative sign. So this guy means we actually have 2 different values for that 4. Here's how you're now going to get your 2 solutions. One of them I'm going to do 2. I'm going to do the plus 4 and then divide by 2. The other solution I'm going to get from doing 2, and then see how there's a minus 4 in here as well. I'm going to do a minus 4 divided by 2. All right, now, real quick, you don't need to go back, but remember, the answers that we got to number 1 were a positive 3 and a negative 1 when we did this by factoring. So if I now go back to this problem, watch now how this is going to play out. 2 plus 4 is 6. And then when I divide that by 2, doesn't that give us the 3 that we got on the front page, right? Same exact answer. On the bottom one, if I do 2 minus a 4, that'll be a negative 2 divided by 2. That then gives us the negative 1 that we got on the front page. All right. So the quadratic formula will work for any of these quadratics. Now, if I ask you which one would you prefer, which one is shorter and quicker and probably a little bit easier, the one that we just did or the one on the front page where we factored it and then just set those equal to 0, right? Which one is easier? That one, right? So this is our preferred method. So if at all possible, if you can factor it, you want to factor it. But remember number 2, we couldn't factor it. So that's when you're just out of luck and we've got to use the quadratic formula, okay? So that's what we're now going to do. We're going to take the one that we couldn't do on the front page, and we're going to use that formula and figure out what these answers were, okay? So here's your quadratic formula. So write this down first. For all these problems, I would write it down. All right, so that's our quadratic formula. In order for us to plug in there, we need to identify what is A, what is the variable B, and what is the variable C. Once we have that, we substitute it. So again, A is the number in front of your square term. So if this is your square term, A is a 1. So that's going to be your A. B is the number in front of the x to the first term. So that's going to be a negative 6. And then the C is the constant at the end, which is a 4. All right, got all that? Then just be really careful substituting in. So now my answers are x equals. This again means whatever B is, we want the opposite sign. So currently my B is a negative 6. So that means when I plug it in, it's going to become a positive 6. Then you have your plus minus. And then you have the big square root. Then I want to square whatever B was. So B is this negative 6 right there. So I want to take the negative 6 and I want to square it. Then you'll see the minus 4 times A times C. So put that minus A4 multiplied by A multiplied by C. Then we have our fraction bar. And then 2 times A is 2 times A1, because our A in this case is A1. All right. All right, so in our next step, just like we did before, we now just want to clean up the mess that's underneath the radical here. So underneath the radical, you're going to do a negative 6 squared. So a negative 6 times a negative 6 is a positive 36. Then you're going to multiply these three numbers together. Negative 4 times a positive 1 times a negative or a positive 4. All right, so negative 4 times 1 is a negative 4. That negative 4 times this positive 4 should be a negative 16. And then all of that gets divided by 2. Okay, then as we get there, you're going to do 6 plus or minus. Go ahead and simplify it. 36 minus 16 is a 20. And then all divided by 2, and we're close. All right, let me go back to that previous problem. When we did this one here, notice how we got this nice perfect square right here? Because it factored. It's a nice number. when we did this one, this is the one that did not factor. Is 20 a perfect square? No. All right, that's because this one wouldn't have factored very well. So what we now need to do, go ahead and simplify 20, because now you need to remember how to do that. Or root 20. All right, Brandon, what numbers multiply to be 20 that are good? Good. Positive 4, positive 5, and then that 4 is a nice perfect square. So I'm going to do 6 plus or minus the square root of 4 is 2 root 5, and then over 2. Looks weird. And right now we're going to say that this is one way that we can write our answer. That's actually the answer. Looks odd. Or we can do what we did before. This really means I have two different answers. That means I could do 6 plus a 2 root 5. And then I could do 6 minus a 2 root 5. Actually, and they're all divided by a 2, so don't let me forget that part. And then do 6 minus, this down, 6 minus a 2 root 5 divided by a 2. So either one of these, if you just want to use the plus or a minus to indicate those are your two answers, that's perfectly acceptable. If you want to write them out two different ways, that's also fine. Okay. Real quick, let's go back to that graph just so you can kind of see what just happened. So this 0 right here, here's 1, 2, 3, 4, 5, and 6. Do you agree this is like 5 1/4-ish, like 5.2, 5.3, something along those lines? Somewhere in there, that's our answer. So now let's take this one, 6 plus 2 root 5, and divide it by a 2. So if I now quit and we do 6 plus the 2 and then do your square root of 5 and divide that by 2, guarantee is going to be like 5.2, 5.3-ish. All right, because that's where that is crossing the x-axis at. Right, but we can't get it by factoring, so that's why we got to use that quadratic formula. Okay. All right, the next one here. This is just saying for the first one, factor this. So first of all, does that factor? I will let you know it does. So now factor it. So the second one, go ahead and factor that out. So if I ask you to factor this, go ahead and do that. All right, Juan, did you get that?
No, I didn't.
Anybody got that yet? Numbers that multiply to be a negative 20, but add up to be 8. And I'm saying, yes, they exist. Yeah, Sage, what do you got?
X minus 10 and X plus 2.
You're really, 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 really close. Because these will multiply to be a negative 20, but a negative 10 and a positive 2 would add up to be a negative 8.
Oh,
So we just want to switch those. So positive 10 minus 2. They still multiply to be a negative 20, but then they'll add up to be a positive 8. All right. So good. Got it started there. All right. That's your factored form. Your x-intercepts, all we do to find our x-intercepts is you take your factored form and you set it equal to 0. So then take that, set it equal to 0. And going back to our last module, your x-intercepts are, again, just when I would ask you, what makes this a 0? All right, so for that first one, Riley, what makes this guy a 0? Good. So one x-intercept would be a negative 10, so our graph's going to cross at a negative 10. And then Julia, what is the value that makes this one a 0? Good. So those are our x-intercepts. So these are our two solutions. All right, negative 10, positive 2. That's what this is asking you. Negative 10, positive 2 are the two solutions to that quadratic. All right, old stuff, we know how to do that. So what I want you to do right now, and we'll see if we can, how much further we get. Off to the right of this paper now, you can't see it yet. I'm going to move mine here now. Use the quadratic formula to set this up. So again, what I want you to do first, if this is your equation, the y equals x squared plus 8x minus a 20. Do this for me. Identify what is your A, what is your B, what is your C, and then plug that into the quadratic formula and see if we at least walk out of here being able to do those two things. All right. The cleaning up of it gets tricky. There's a lot going on with it. And then we'll finish this tomorrow. So right now, show me that you know how to find A, B, and C, and that we can plug it into the formula. All right, Yusuf, what do you think A was? 1. All right, B? 8, and C? Good. As long as we are in standard form, and this is in standard form, this is your A, this is your B, this is your C. All right. Then from there, we're just now plugging into the quadratic formula. This is the quadratic formula. So now just check to make sure that you have the same thing that we would have. The opposite of B means if this was a positive 8, when we plug it in here, you should have had a negative 8. All right. Then if I'm going to square the B, my B is again an 8. So in this spot right here, I am going to plug in an 8, and then I'm going to square that. And then we do times A times 4 times A times C. A is the 1. C is that negative 20. In your denominator, so in this spot, I'm going to do 2 times A. A is just a 1 right there. So this becomes a 2 times a 1. That's what this should look like. Say that one more time. For your final answer? You're warm. You should get negative 10 and 2. All right. Now, I don't know if we're going to get to that today. We're going to stop right there. But what Jackson just said is when we solve this, we better get these two answers. It's just a different way of doing it. Okay. But bring this tomorrow. We'll finish this up tomorrow. Like I said, we weren't going to get through all of this. We'll finish this problem. We'll do the ones on the back page, and then we'll see how you can do it on tomorrow night's homework. Shoot. I'm doing it now.